This is Push That Rock with Simpson Math. This lesson covers probability density functions. Let's get started. Okay, so a probability density function, we frequently just call them PDF, not to be confused with a portable document format or file. So in statistics, we study continuous random variables, and we represent them with a capital letter X. And continuous random variables are things like wingspans or baby weights or volumes of gas. Continuous random variables have associated PDFs denoted with f of x. And these functions, these probability density functions, have these characteristics here. First of all, they're always positive, okay, over their domain. Second of all, the integration over the domain equals to 1 because let's go to point 3 and then I'll back up. Now the limits of integration assumes the x value can take any value, but if the domain is from -5 to 5, well then this would be -5 to 5. The third characteristic is if you want to know the probability that the continuous random value variable is between two measurements, if wingspans are between 10 inches and 11 inches, well then you integrate the associated probability density function from 10 to 11. So that's why this is going to be 1, is because we know that the probability of the entire possibilities for the continuous random variable will sum up to 1. The most famous probability density function is the Gaussian distribution, aka the normal curve. We've been looking at it a lot. So here's the equation for the normal curve with the parameters mean and variance sigma squared. So this is the typical symbol for variance, sigma squared. Sigma is simply the standard deviation is sigma, which is the square root of the variance, and this Greek letter mu we use for mean. Now if we let the mean be 0 and the variance be 1 over 2 pi, and then the standard deviation be the square root of that, which is 1 over the square root of 2 pi, then the normal distribution looks like this. So a normal distribution where the mean is 0 and the standard deviation is 1 over root 2 pi looks like this. Now, we've seen this before, day 1 of Calc 2 class. We said, hey, that's not easy to integrate. We need approximation methods. So we're not going to be integrating that. But if we did integrate it from -infinity to infinity, it would equal 1. In other words, we're saying all of the total area under this curve equals 1. And the curve looks like this. At the mean, it's got its highest point. It has the inflection points where it goes from concave down to concave up above the 1 standard deviation above the mean and 1 standard deviation below the mean. So above 1 over square root of 2 pi and -1 over square root of 2 pi. And then by the time it gets out 2 standard deviations from the mean, it's already close to the x-axis and it'll get asymptotically closer thereafter. And in stats class, we would integrate from, say, here to know what's the probability that a measurement is 1 standard deviation below, somewhere between 1 standard deviation below the mean and the mean. Of course, that integration is difficult. We'd have to use integration techniques, approximation techniques, but there are published tables to help us with that. In your homework, you're going to be doing a lot of these types of problems and sometimes verifying, but if you can get these first two characteristics, you have verified that a function is a probability density function. Success starts here.